Another concept from geometry that we're going to use heavily in coordinate geometry is the idea of a right triangle. Now, what is a right triangle? Let's review a little bit of notation again first. If we have a triangle whose three corners or vertices are at points A, B, and C, we call it triangle ABC, and we write a little triangle followed by the letters A, B, C. In this diagram, we see at this corner, which we'll call angle B, naming it with this angle symbol, followed by the label on the vertex or corner. And at that point in the diagram, we see a small square. And what that small square means is that that angle is a right angle. A right angle, sometimes called a square corner, is where two perpendicular lines meet. So two lines meet and all of the angles are the same. Each of those angles is called a right angle. We associate right angles with the measurement 90 degrees, but it isn't that we define a degree and then a right angle happens to be 90 of them. We define a right angle based on things being perpendicular, and then we define a degree so that every right angle has 90 of them. So, angle B is a right angle, which means that triangle ABC is a right triangle. Right, a right triangle is one where one of the angles is a right angle. In a right triangle like this, the side AC opposite the right angle is called the hypotenuse, and the sides AB and BC that touch the right angle are called the legs. Right, so the side opposite the right angle is the hypotenuse. The other two sides are the legs. Now, why do we like right triangles so much in coordinate geometry? Part of it is that we know a lot about them. We'll review some of that later. And part of it is that when we have a coordinate plane, we've got all these perpendicular lines. Right? We have the horizontal grid lines and the vertical grid lines, and they're perpendicular. Which means that if we have a diagonal line segment, that is, a line segment that isn't horizontal or vertical, we have a natural way to draw a right triangle with that segment as the hypotenuse. So here I have 2 points. I have the point -2, 3, so that'll be here. There's point A. And then I have point B at 3, -1. Here's point B. And I can draw a segment connecting those. Then I can easily choose a point C so that angle C is a right angle. Triangle ABC is a right triangle. I could choose this point up here, and then my legs would be this vertical line and this horizontal line. Or I could choose this point down here, and then my legs would be these two. I'm going to make this choice and put C at, let's see, X is 3 and Y is 3. Notice, X is 3, Y is 3. Not a coincidence. If I'd made the other choice, I could have put my point at X is -2, Y is -1. And again, notice, X is -2, Y is -1. Not a coincidence. To be on these horizontal and vertical lines, Well, to be on the same horizontal line is to have the same y-coordinate, and to be on the same vertical line is to have the same x-coordinate. So our third point can either be on the same horizontal line as A, that's having the same y-coordinate as A, and the same vertical line as B, that's having the same x-coordinate as B. Or we can put it on the same horizontal line as B, that'll be the same y-coordinate as B, and the same vertical line as A, that's having the same x-coordinate as A. Either way, given 2 points that are not on the same horizontal line and not on the same vertical line, we can very easily write down the coordinates of a point that makes up the third corner of a triangle like this. And it's going to turn out that that is useful to us in a variety of ways.